So are you able to see the screen?
Yes, sir.
Okay, thank you. Good morning, students. Today we are going to discuss the other program, lab program. So third and fourth. So both are similar. There is a slight change in the code, only just a few lines. There is a change. So I will tell what are those, how it will be different, 3 and 4 program. Okay. So that is about cube. So we have to construct a cube, three-dimensional cube, and we have to spin it in a three-dimensional space. That is with respect to two different projections. Okay, so both is like draw a color cube, draw a color cube. You can able to see here question third and fourth. Draw a color cube and spin it using OpenGL transformation matrices. By default, they are asking in the third question. So here, but they are specifying something. Draw a color cube and allow the user to move the camera suitably to experiment with a perspective viewing. So we have to, so manually we have to perform this function. This is automatically the cube is going to spin. Here we have to, using a keyboard or mouse interface, we have to perform the spinning of this color cube. Okay, so both are same. If you understand one, just another one, just simple, that will go easily. Okay, so let's start with the basic one so that you can we can differentiate with another one. Okay, so simple agenda is simple. We have to draw a color cube and that will contain 8 vertices, your cube, and 6 faces it contains. 8 vertices and 6 faces, your color cube. Okay, so after constructing, you have to, using either keyboard or mouse interface, you have to spin the cube, or you have to change the direction of the cube. So as I said in the third program, the whenever you start executing the program, you no need to give any input manually. So previously means we used to give the number of divisions in the yesterday program so that it will perform the division. But here no manual input. Just if you build the your program, and if you run that, so directly you will get a pop-up window. So there your cube is started spinning in the by default position. So using either keyboard or mouse interface, so we have to spin the cube in a different direction, nothing but X direction or Y direction or Z direction. So we have to perform that activity. Okay, that is all about your third and fourth program. Okay, so before moving to this program, we need to understand so what do you mean by projection? So what are these two projections, these two type projections, and what are the conditions we are going to taken in these two projection. Okay, so we'll understand some basic theory concepts and we'll come back to the program. Okay, so this is what the intention of the program. So let's go to your projection. Yes, so projection. So what do you mean by projection? We have already understand projection plane or a surface or a screen or something like that related to output devices, right? So same thing. So projection is nothing but, so as of now, so we have gone through all the two-dimensional. So whatever we are seeing through our eyes, that is a two-dimensional object. But whenever you are planning to convert your three-dimensional object in a two-dimensional plane, okay, but the object is in three-dimensional, but you are going to portray the same object in a two-dimensional perspective, two-dimensional view. Okay, that transformation or that conversion is called as a projection in general. Okay, or nothing but you can say mapping also. We are going to mapping from 3D to two-dimensional viewing. Okay, so that is about a projection, simple projection. That is but conversion of your three-dimensional object or mapping or transformation of three-dimensional object over a two-dimensional plane. Okay, so that view plane is displayed surface. What is that view plane? So whatever we are going to visualize at the end, that is called a display surface. Nothing but we can call as view plane. Name itself indicates the plane where we are going to view the object. The 3D object is represented as two-dimensional object over the view plane. So that is a simple definition for a projection. So in that we have two different types of projection, perspective projection and parallel projection. So you can see in the diagram, you can understand. So what is that meaning? Perspective and parallel projection. So we'll discuss one by one and we'll see what is the difference between these two type of projection. So we'll consider first perspective projection. So look at this diagram. So this is the projection plane. We have an object AB. You can say a line segment or whatever it may be. And we have, this is the view plane. And we have one more point called center of projection. Nothing but, so where your object is going to be visualized or viewed, that is the center of projection, COP. In short form, you're going to call as center of projection. So in this case, the object, the position, whatever the object position are transformed to the view plane along the lines that converges to a point called center of projection. Okay, so there is a line segment AB and you just look at this, these rays are started, right? These are the projection lines. So that is what the line they're telling, lines. So these are called lines. Okay, so but these two lines are meeting at some particular point. You can observe here. So it is started here. Here also it is started from this side, but at some particular distance, your both the lines are joining. So that there will be a reference point. So that point is called as center of projection. So in this case, in case of perspective projection, the lines are not parallel because these two lines will meet at some particular distance or some particular point. So it may be here or it may be somewhere other. Okay, so either maybe 1 meter, 2 meter or 2 feet, 3 feet, depends. But at some finite distance, these two lines are going to meet. So that is a perspective projection. So these are called a projector. So how we are going to view the object. But there is, you can observe, there is a, see, there is a sizes, maybe there is a change in the size because it is converging. So here initially your object is this much size, but when you are looking that, so you may be observed like this, A dash, B dash. Okay, so that is, you remember two things here. In this case, COP will be a finite distance, means center of projection will be finite distance and the lines are not parallel. Come to the parallel projection. So in this case, what will happen? Just you see same diagram only, AB only, but there COP is infinity. Means these lines are not at all meeting at any point throughout the process. Okay, so these are the projectors. See, these projection lines are parallel to each other. So these will not meet at any point. That will be infinity. So see, look at this, and these lines are parallel. Understood? So that is what they have given here. Projection lines are extended from the object and intersected the view plane. So it will be intersect the view plane. This is the view plane, but it will, these two lines will not be intersecting. Simple. In parallel case, the projection lines are parallel and your center of projection will be infinity. In case of perspective projection, your lines are not parallel and your center of projection will be finite, means it is having some distance. It will be meet at some particular point, but in this case it will not meet. So that is the basic definition you have to understand in case of perspective projection and parallel projection. So same thing they have given here. So this is about perspective projection. So you look at this diagram, we have x-axis, y-axis and z-axis because we are representing our three-dimensional object. Okay. So and we have the same thing here in the previous case, whatever you are considering, just I'm showing in a same thing only, just will consider like this. Okay. So this is a width and this is height. Width and height. This is the projection plane. Front view, front front side. This is, and this will be the back side. See, so this will be the back side image or whatever it may be. This will be the front, whatever the user is going to observe, and this will be the width and this will be the height. And your aspect ratio, how you are going to calculate aspect ratio? W divided by H, width divided by height. So that will give the aspect ratio. So that is aspect ratio equals to W divided by H. And you can mention these points as like this, the coordinate system X and Y, Z axis, we can mention like this. So in order to find out these 2 points, so this will be near, bottom, right, and this point will be near, top, left. Okay, diagonal vertices. Okay, and these are the lines, projection lines, whatever we have discussed. See, so these are called projection lines. In the previous case we have seen, right? And these will meet at this origin. How here the COP will be there, no, center of projection. So that is what this point COP, and it will be at the origin. Okay, so this is what X, Y, Z axis and your projection plane, aspect ratio, and whatever the diagonal vertices, opposite vertices we have considered, and the corresponding values, how you are going to choose in order to mark this point near, top, left. So the near in the sense, this is with respect to this. So this will be the near. So this distance, and this will be top, and again left side. So if you come to this point, this will be bottom, right side, and again this will be the near with respect to origin. So what is the distance from here to here? Like that we are going to identify our vertices for any object, whatever we are going to draw. It's the same thing. See, so this is our eye. Nothing but eye means that is center of projection. So whatever we are sitting here and we are observing the object here. Okay, so this is called view volume. Whatever the volume which is present in between this one in the projection lane, that is called view volume. Okay, these are the called projection lines. Okay, see, these all actually this is the object. So see, all the projection lines are coming like this. These are not parallel, and these will be meet at some particular point. So that is nothing but our eye coordinate system or your camera, so that you can able to observe this picture or image on the screen. And this distance is called near, and this distance is called far. So whatever the initial, so object we are going to, that distance will be the near distance, and that far, that the final whatever the object we are going to visualize, that distance we can make it as far. So directly you cannot see when you are going to see the object, but back end. So this is what the distances are we are going to consider. So when you are looking at the object, you can able to see the directly the object. You can't say directly what is the near and far. Okay, but this is the distance near and far with respect to viewing of the object in a three-dimensional object in two-dimensional plane. So I will come back to this. Okay, so and this is the parallel projection. Same thing again. So these are, see here, they will not meet at any point. In that again 2 different cases will be there. So you just you are sitting outside this plane and you are going to view the object. So that time your near and far calculation will be like this, and these will not be meet at any particular point. So see, all are parallel lines only, projection lines. So these will not, the infinity, COP will be infinity in this. But in the second case, you can consider you are assuming that you will be at the center. You will be up the, you are moving inside that volume. Okay, inside that projection plane. So your eye is, see, here outside, here inside. So that is what, with an orthographic projection, the eye can be inside the view volume. In that case, the near clipping plane lies behind the eye and the value of the near is negative, because you already gone some distance from outside to the inside. So then you are just far away from near. So whatever the near point will be there, then that value will be negative, because see, look at this, this is the near, but now your eye is here. Then what is this? So this will be the negative distance, negative minus near. Okay, but here, so this is the near point, but you are there at this location. Then this is the positive distance, that is plus near, like that. Then there is no change in the far value, it will be positive only, because still you have to reach here. But in this case, the view volume is the rectangular solid between the near and far clipping planes. So this is how the consideration we have to do with respect to parallel or perspective viewing. So these are some of the differences with respect to parallel projection and perspective projection. So already we have seen some of the differences. So parallel projection represents the object in a different way, like telescope. You can represent or you can visualize in a different ways. But in perspective projection, you have to represent the object in three-dimensional way. Okay, but in this case there is no restriction. You have to represent only in any particular system. In parallel projection, so these effects are not created. So in perspective projection, objects that are far away appear smaller and objects that are near appear bigger, obviously. So when you are looking through your eyes, whatever the object which is near to your eyes or a camera, it will be look bigger. So suppose if the distance is at some far away from your camera or to your eyes, then object looks smaller. Here there is no such type of concept only, because there is no center of projection only, no, because parallel lines, you will not see the end. Okay, so that is why effects will not be created in case of parallel projection. And again, the distance of the project object from the center of projection is infinite. We cannot measure the distance, as the lines are parallel. There is no COP, they will not meet at any point. But here the distance of the object from the center of projection is finite, means we can measure, we can say, so this object is at some this distance, whether it may be in 1 meter away, 2 meter or 3 feet, 5 feet, 10 meter, something like that. We can have some particular finite distance. And parallel projections can give the accurate view of the object. So there is no diversion or conversion of your projection lines. But in case of perspective projection, cannot give the accurate view of the object. Yes, of course, because initially when you are looking the object at some particular distance, it will be like some original image. If suppose if that image passing through that whatever the camera we are observing through eye, right? So then that object will not be seen. Look at this. Whatever the object you are seeing, same thing you can able to see here. There is no change. There is no distortion in the image. The image will be perfect. But in case of perspective viewing, this is the, suppose you assume the original image, or this is the original image. So after will be distorted in the object. You cannot get exact quality of the image or the object. So that is what, that's what, there is a change in width and height. So obviously your aspect ratio will changes. So that will result in disturbance in the picture. But here no such cases. That's what this point can give the accurate view of the object, but here cannot give the accurate view of the object. And the lines of parallel projection are parallel. Here they are not parallel. And projector in parallel projection is parallel, but here in perspective projection is not parallel. And we have two different types of parallel projection: orthographic and oblique projection. You no need to go in depth this, just you know what are the types. And here three types of perspective projections are there: 1 point, 2 point, and 3 point perspective projections. and it does not form a realistic view of the object, it forms a realistic view of the object. Okay, realistic view of the object means whatever it is there, just it is going to display, that's it. Okay, so we are not doing any manipulation in this case. So these are the couple of differences between your parallel projection and perspective projection. So now we'll move on to our program. So now you have some idea about what you mean by projection and what are the different types of projection and how we can visualize the object in case of parallel projection or in case of perspective projection, and the pictorial representation of for the both the cases. Okay, so by keeping this in mind, so we can move to our program so that you will understand. Now we have some basic idea about projections. Okay, so that is what the third program, draw a color cube and spin it using OpenGL transformation matrices. Yes. So again, as usual, so before that I will explain this diagram so that you will understand better. Okay, so this is the cube. So three-dimensional cube. So I have constructed and I have marked the reference points also, vertices also. 8 as a side. There are 8 vertices and 6 faces we have for this cube. Okay, color cube. So what is this vertices we are going to consider? As we know that 0, that is indicates black color. So you know, you don't need to repeat all these colors because you already know the table, whatever we have shown in the previous class, that RGB color model. So 00 means what, which color, 001 means which color. So no need to just again, even though it is represented here also, so they have given what color that is, and black color. So started with this vertex 0 and 1, 2, 3. Okay, next 4, 5, 6, 7. So total we have from 0 to 7, total 8 vertices we have, and the corresponding values for that and which color it belongs. And now we have to identify the faces. What are the faces? So look at this 6 faces I said. What are those 6 faces? We'll see. So one is like 0, 1, 2, 3. 0, 1, 2, 3. So this is one face. Okay, understood. So next 4, 5, 6, 7. So this is another face. So 2 faces over. Now 1, 2, 6, 5. So that is another face. Next here 2, 3, 7, 6. So this is another face. So total now 4 we have finished. Next 0, 1, 5, 4. So this will be the other face. Next 5 faces over. Next 0, 3, 7, 4. So this will be the 6th face. So just you assume, so this whatever this box, this is the one face, and this so second one, this one second face, and again this side face. So this is the left side and this is the right side face, and this is the bottom face, and this is the this is the top face, and this is the bottom face. So we have total 6 faces for the cube and 8 vertices. Okay, so just you know this, and this is an x-axis, again y-axis and z-axis. So we'll go to the program. Now we have the coordinate points and how many faces are there and which are those faces. We have to, so we have to make it, we have to write down, and then we are same thing I'm going to use in my program. So just again same thing, include glut.h. So I'm going to use glut library function, and vertices total how many vertices I'm going to consider 8 vertices of 3 axes, right, x, y, z. So that is 8, 3. So these are the values. So you have to remember these values because the value ranges from 0 to 1, and some of the values in the negative plane and some of the values in the positive plane. That's why. So that negative indicates the that quadrant, right? So total 4 quadrants we have: plus, 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 minus, minus, plus, minus, minus. So based on that, these values are written. So based on the quadrant, which quadrant it belongs. So in order to construct in order to draw the vertices. So these are the 8 points, whatever we have seen here. So yeah, this one 0, 1, 2, 3, 4, 5, 6, 7. So these are the vertices values. And color, so color combination, what are the colors you are going to give? Because if you are not giving the different color, then it will be taking the same color for the whole cube. So that's why differentiate, I'm giving the different color for my vertices. So similar here also same thing, 8 cross 3. And again theta, so because as it is, as this is happening at the origin, so your theta value will be 0 0 0 for all the xyz axis. Because as I said, I'm going to consider, or I'm going to spin my cube with respect to center, nothing but origin. That's why your theta will be 0 0 0. And axis value is equal to 2. This is the rotation, axis rotation means speed, how much speed your your cube is going to be spin. Okay, this is about some of the initial declaration. Next, again directly the control will goes to the main function here. So this already you know, no need to repeat again and again. So here this argc, that is argument character type, and whatever the value we are passing through the argument, it will be stored in the form of a string. And this argv argument vector, it is going to pointing to these values, string values. And this is for initiation, means it is going to map your command prompt window with the OpenGL function. And glut init display mode function, that is glut double and glut RGB, glut depth, same thing. As we are dealing with a three-dimensional object, so we need depth information in order to enable the depth information. So in order to visualize the, in order to view the invisible surface of the or faces of the cube. Next, so glut in window size, again same thing, repeating 500 500 will be the, that is nothing but W and H, width and height. So whatever we have seen in the diagram, right, previous diagram, so WH aspect ratio calculation, that value, this is W and H. And glut create window, just I'm giving rotating a color cube naming. And now actual again same thing, glut reshape function, my reshape function, same thing in the last class whatever discussed, same function I'm going to repeat again, same thing. See, there is no change in this. My reshape function in W int H, again viewport, so where I'm going to visualize my object, so there will be a change in the W and H size. So then GL projection, so that is the current matrix, whatever the value means, whatever the matrix value of the object we're going to visualize over the screen. And after that load identity, it is going to erase the current matrix information, means it is going to reset to 0. And if suppose W value is less than or equal to H, so we are going to use GL ortho, this function. Okay, so for the three-dimensional space, so GL ortho, so I will show that the GL ortho function here. See, so GL ortho, nothing but what are these values it is taking, no, here these values minus 2.0, 2.0 minus, so those value will be X minimum value, X maximum value, Y minimum value, Y maximum value, and near value, far value. We know that already, X min, X max, Y min, Y max, and these two concepts are added in case of three-dimensional. But in case of two-dimensional, what, GL ortho 2D, we have only these four parameters. But as this is three-dimensional, we need to calculate near and far distance also. That's why you are going to use this function. So just look at this in this diagram. We have, so these are the points. This is the X minimum and Y minimum, and this will be the minus near value. Okay, means this will be in the negative direction. So if it is in the positive direction, again that will be plus near. Okay, so this is how the, what are the parameters we are considering in case of GL ortho function. If suppose if you're talking about axis like left, right, bottom, top, near and far, same thing, just it is replaced with the symbols, left side or right side, bottom or top, like that. Okay, so this near and far distance will be measured from the camera with respect to eye coordinate, whatever we have seen, right? So that from with respect to that reference point only, you are going to say that object is near or far. Okay, so that value also we are going to, pass as the one parameters to your GL ortho function. So this is what we are using, GL ortho. Okay, and that height and width we are going to calculate, it's the floating type value. And next, if that is the case, if W is less than or equal to H, so this will, so if just reverse else part, so same thing. So just you are going to reverse the word. See here, H divided by W we did, here W divided by H we are going to do. Okay, so just opposite. else part. If this condition true, we are going to perform this. Aspect ratio we are going to calculate like this, h divided by w. But if reverse means else means the reverse, see here hw, h divided w, here w divided by h. So that's it. And here after modifications or after changes has been done with respect to your height and width for the present object. So those updated or modified values are going to be stored in the GL model view matrix. So that will be again of the matrix mode. So here just normal values it is going to consider the current matrix value. So this is after changes has been made, then the resulted output is going to be stored in terms of a matrix. Those values it is going to store. So this is about my reshape function. So and again control will once that function finish, it will come back to this main function. Again glut display function is going to execute. So it again will control will go to glut display. Glut, just a second, glut display. Yeah, here white display. So this is just again display callback. We are going to clear the frame buffer and the Z buffer, rotate the cube. So many functions we are going to perform in this. So that is what clear the buffer, and your depth information also it is going to clear, and load identity again it is going to erase the matrix values also whatever we have stored in the previous case. And we have using rotate because we have to spin the cube. So that's why we are using GL rotate function and theta of 0 because we are dealing with 3 axes, right? Theta of 0, theta of 1, theta of 2 means with respect to x axis or y axis or z axis. So that is rotate function we are going to use with respect to which axis you are going to spin your cube. Okay. So and the color cube function we are going to call. So where is the color cube? Here. So we have the color cube function, means now we are going to construct the color cube with the input value. So as we saw in the this triangle, just a second. Yes, so these values I'm going to consider now. So previously I told you which what are the faces we are using. So here with the explanation it is there. See, so polygon of 0, 3, 2, 1. So nothing but this face. 0, 3, 2, 1. So this face. Okay, like this we have all the 6 faces for here. Front face, back face, front face counterclockwise, back face clockwise, front face counterclockwise. This direction they have mentioned. If you are unable to understand by looking at this, you can easily understand. Just you take this point, you identify here so that you will get the face, how it will be. Or simple, you understand top, bottom, left, right, and again this one front and back. So like that you remember. Otherwise 6 faces, front, back, top, bottom, left side, right side, total 6 faces you remember like this. Otherwise it will be confusion for you by looking these clockwise, counterclockwise like that. Okay, so that will be better. So all the values I'm going to pass. So those coordinate points, vertices points here. Okay, so same thing. You just these are the points. You no need to worry about this. What are these numbers? How they have written like this? Like this means here using this faces concept, they are writing these values 4, 5, 6, 7, 2, 3, 7, 6, 1, 5, 4, 0. See here 1, 5, 4, 0. This is one left face. So like that they have written. You no need to worry about this. Just you have to understand how we are going to consider the faces and the corresponding vertices values for that face. That's it. We are going to just map the vertices to faces. Now this polygon function called, right, with this input value, again we'll go back to polygon function. By taking those values A, B, C, D, so those values I'm going to use GL polygon function. Again I'm going to assign color for all the vertices. So in order to differentiate, so each and every vertex is having a different color combination. Color again 3F means that is a XYZ 3 axis we are going to consider. That's why, and it's a floating point value. So colors of A, again vertex calling, it is going to call as vertex of A, so that it is going to consider the first one, and again for B second one. So like that. So we are going to find out all the A, B, C, D. So by taking these A, B, C, D 4 values with a different color combination, so it is going to construct your polygon. Okay, then your cube has been constructed now with color. So that end of this function. Okay, so we are going to identify the vertices with the help of the input values along with the color input colors also. Okay, so that so once this is done, your cube is ready to display. But we have to render it, means we have to connect to our OpenGL function. So once that's done, so where is the control? Here, color cube is over. Now GL flash just it is going to draw the objects. So glut swap buffer means what is the use of this swap buffers? So as I said, your cube is about to spin, right, from left to right or right to left, from top to bottom, or so any just movement of the cube, what will happen? So suppose if you consider, so this only, so this is the initial display of your cube. You are thinking that, so like yes, okay, 1 2 6 5, this is at the top, this face is at the top. Suppose if cube is pinned, so suppose either it clockwise direction or anti-clockwise direction, is this face is present at the same location? No, it will change, right? If you little tilt, this face will come this side, or again if you once again if you do, so this face will be coming at the bottom. So like that the values are going to be changes, the values of the faces are going to be changes. That is what the swap buffer, it is taking care of those values, that swap buffer. So just those values, faces will moving from one direction to other direction. Now it is front, after that it may go for back, or it is left side, or it may go to top, bottom, so don't know. So that whatever that swapping is done, so that will be taken care by this glut swap buffer function. Next, once that is done, we'll come back to our original. So now glut display function over. So next it will go to glut idle function spin cube. Now how it is spinning? So just we have only draw the object, but how it is spinning? So we have to spin it. Now only cube is constructed by using this function, whatever we have discussed just now. So we'll go to the spin cube function here. Theta of axis plus equal to 0.0. This will controls the speed. So here we are going to give the value. Here if you change the values, your spinning of the cube is going to be varied. Whether you can increase the speed, you can decrease the speed. So that is what the speed of spinning the cube. You can control that in this using this function. Theta of axis equals to theta of axis plus 0.05. And if theta of axis is greater than 360 degree, then theta of axis is equal to minus 360 degree. Means so your once object is completely 360 degree, it has to be rotated, and again it will come to the negative direction, and it is rotating. Means it's complete one cycle it is going to finish. Okay. So then after that, initially you have display your cube. After performing the spinning with respect to that 360 degree concept, again you are going to display. It's keep on display only. So post display means after performing that spinning, then you are going to show the object on the same plane only by keeping the current window. You no need to, again you will not display that spinning of the cube in some other window. By keeping the current window in the same output window only, you are going to show the spinning of the cube, and also the spinning with respect to different direction, either X direction, Y direction, or Z direction. Everything will be happening in the same window. There is no separate window for just normal spinning of the cube. And by using a keyboard and mouse interface, you have to change the direction of the cube spinning. No, both will be done at the same window. Okay, that is what the post redisplay will also helps in order to perform that in the same current window. So that is about spinning of the cube. Next, now interface. So using mouse function, we are going to control the spinning of the cube in a different direction, either x-axis, y-axis, or z-axis. So we'll go back to the mouse function. See, this is how we can able to interface. Wide mouse function, button, state, int x, int y. So coordinate values we're going to consider. So if suppose button is equal to left button, okay, so left button, and state is equal to glut down. So axis is equal to 0. You can assign to one axis, x axis. So if suppose it's left button, I'm going to assign left button to x axis. So just I'm going to consider like that. So again, middle button in your mouse, there is a middle button, right? For that, some other axis. So again, right button. So again, we are going to assign to the third axis. Like this, we are going to interface our mouse with respect to change the direction of the spinning of the cube. Okay, so this is the interface of your mouse function. So that's done. So interface is also done. Now again, same thing. We are going to enable your depth function in order to visualize your invisible screens, and glut main loop. So everything will be controlled by this main loop function. Okay, so that's about your program. So we'll go for the execution. So same function written here, just to make a build solution for that. It's already done. So are you able to see the spinning of the cube?
Yes, sir.
So this is the current window I am going to use. So where my cube is rotating with the speed 0.05, we are given in the spin cube function. If theta of axis is equal to theta axis plus 0.05. So if you change the value, you can increase the speed of the spinning, and you can decrease the speed of the cube spinning. Okay. So now, so I didn't perform anything else. I'm not clicking mouse button right now. This is just default output you are going to get. So we have constructed the cube, but you are not able to see the other faces also, right? Now you can able to see simple one square shape. That's it. That's what your three-dimensional object you are going to represent in a two-dimensional plane. So now I am going to press. You people are not able to see here, but now I am pressing left button, mouse left button. You just see the changes. What changes are going to be? See. So are you seeing the difference? It changes the position, spinning speed is same, but position is changed, right?
Yes, sir.
And I said the vertices values, color values we assumed, right? See, look at this. So this vertex is blue color, and here yellow, white, this pink color, red color, green, yellow. So like this, we have a different color. So while coming, inside your viewing volume, your color values will be like, that brightness is little reduces as you are moving inside your cube. But at the vertices, you can see at the sharp vertices, your color, you can able to differentiate different colors. So that is what we have mentioned here, this color combination. See, green, yellow, red, magenta, blue, cyan, like this. Okay, so same thing you are visualizing here. Fine. Now now left button I pressed, right? Now I will check with some other. Now right button I will click. Now is it change the position, the spinning position with respect to different axis?
Yes, sir.
Now I will press center button of the mouse. See. Now this will be, now your whatever the initial spinning, no, that is left, that is gone. You now your reference point will be this one. Whatever current is it is spinning, no, that is, it will be taken as the current matrix value. So again, if you press something, it will again changing like this. The even phases also moving to different direction. That is what your glut swap buffers. So it's storing the values, and your GL matrix mode, GL projection one function we have seen, and again GL matrix mode, GL model view. That is one more function we have seen. So these changes are going to be observed and stored in the matrix format. See, just I have performed all the three activities. Now you see, I'm going for the left button. I'm going to press now. See, now it is again something different. When I started, it is something different. Now it is taking the previous coordinate value, and with that with respect to that value, it is going to start spinning now. So now I will press right side now. See, now it is spinning in a different direction. Now I will press center button. See, clockwise, anti-clockwise, based on the when you are going to press, and which button you are going to press. Based on that, it will take the direction and it will start spinning. Now I have finished 2 iteration, means 2 times I pressed all the buttons. Then randomly you can press left, right, button, center, anything. Just I am showing the flow. So now I will go with for the third case, same thing. I will press again left button. Again I am pressing right button. Again center button. So like this. Now I randomly am pressing all the buttons. So see. So just so like this you can rotate your not rotate, actually it's a spinning. If you want, you can change the value here and you can increase the speed here instead of so we'll give some 5. So have you seen the changes? Hello? Hello?
Sir.
So are you observing a difference in the spinning speed? See, previously it is very slow, right? 0.05 I give, now I will change to 0.5. So your speed is started as like this, you can able to perform. That's it. So that is about your spinning a cube. So this is how the program is going to work. So if you have anything, please let me know. So we will discuss. So just I have taken some of the screenshot because I am not able to show the spinning here, right? But with the spinning in a different direction, I have taken. This is at some particular position, and this is what I can view in a different coordinate values, and this is what. So like that, just I have taken the different snapshots of your output. Okay. Anyhow, uploaded the programs in that CGLab programs. Anyhow, I am uploading the video also. So yesterday, all the classes I am uploading. If anyone want to, just you go and listen again, and you will understand. So that's it about today's class. So next class, I will finish the second one. For that, I don't need much time. Just only slide. Only where is the difference I have to address. That's it. Other, if that is fine, means we can finish it off. In next class, I will finish this also. So then by that we can finish 7 program, and we left out with 2 programs only out of 9. So that's why. So because we didn't take lab for a long time, that's why I'm covering the lab syllabus also. After that, I will start 4th module. Anyhow, these concepts only in 4th module it is coming. That whatever 3-dimensional viewing and all those things, perspective, parallel, projection. That's why I've taken some theory class and then I have started the program. So next class I will finish this in Tuesday class, so that we will finish 7 programs by Tuesday, and only 2 program will be left out. That is teapot and Bezier curve algorithm. You have to construct a Indian that national flag, animate the flag using Bezier curve algorithm. So this and this will do in some other class after your internal. Okay. Fine, thank you. If anything, please let me know. So I will upload this PPT also and the recorded session also. If anyone want, you can listen.
Sir, when is internal, sir?
My internal, 1 second.